course, he only knew what we knew back then, and he didn't have all the information that now later on the superstring theorists had and could work with, right? Yeah. You could go back to my lives from that time and watch all of it go down. I really did do that. Yes, I mean it's live. Under the live tab. And the day after that, I went to the bakery, and that's how that whole thing went down as well. Yeah. So, yes, indeed you could go to the live tab, my live tab on the channel and look at the lives from that time. It will also cover a lot of these topics. In my sadness, I worked very hard at that time. I love your stream, so Andrew. Oh, thank you, Steven. Thank you. Thank you, thank you, thank you. I'll keep going for a little bit longer, okay, guys? I just want to cover a little bit more about the string theory stuff. And then, excuse me. And then I want to find a different reference that I can share with you. If she's freaking out, I have to see it. Yes! You should go see it. Just search. I think I called it Election Night or something. I think that's when I started to do face lives. That was the night. In despair, I showed my face. I was like, oh my God, I've shown enough emotion. Now I have to show my face too. Remember, because I used to not actually be on the... I used to not really be on the... on the camera. I used to be a voice. So I used to just be a voice. And then on election night, I showed my face because everybody was so cozy and chatting. So on Einstein's third try at a great unifying theory, he failed, mainly because he lacked the symmetry that would unite gravity and light. He, of course, was acutely aware that he lacked a fundamental principle that would guide him through the thicket of tensor calculus. He once wrote, "I believe that in order to make real progress, one must again ferret out some general principle from nature." But that is precisely what the superstring provides. The symmetry underlying the superstring is called supersymmetry. So it's called supersymmetry or SUSY, a strange and beautiful symmetry that unifies matter with forces. As mentioned earlier, subatomic particles have a property called spin, acting as if they were spinning tops. The electron, proton, neutron, and quarks that make up the matter in the universes all have spin 1/2, and they're called fermions, named after Enrico Fermi, who explored the properties of particles with half-integral spin. The quanta of forces, however, are based on electromagnetism with spin 1 and gravitation with spin 2. Notice that they have integral spin and are called bosons. So I mentioned in the particle family called bosons, and those things have integral spin. Oh wow, happy birthday. The key point is that in general, matter is made of fermions with half-integral spin, while forces are made of bosons with integral spin. Supersymmetry unifies fermions and bosons. This is the essential point that supersymmetry allows for unification, which Einstein wished for. In fact, supersymmetry allows for a new type of geometry that has even surprised the mathematicians, called superspace, which makes possible supermarble. In this new approach,